All right, here we go with the continuation of the notes for lesson 11.4. The first part of 11.4 talked about regular polygons, and the last part talks about composite figures. That's the main idea here, and it really is pretty simple and straightforward. Composite figures are figures composed of two or more geometric figures. And so it's basically like putting these figures together. Well, area of composite figures then is the area of all the parts put together. And that's all we have to imagine here, is that we can take a figure and break it down into its individual parts and combine their areas to get a total area. So this first example seems like it'd be really obscure, but we can actually find the area of the shaded part of this, the black part of this yin yang symbol pretty easily. All right, it's a well-known symbol from Chinese culture. And we're going to suppose that it's actually made up this way. We've got a larger circle with a radius of 24, small circles here and here have a radius of 3, and then this S curve is actually a semicircle bubbled out here and then another one bubbled out here for the white. And what is going to really help us out is if we can identify the semicircles by drawing a line straight down through the middle. And so that's what we're going to do first. Okay, so we're just going to try and find a line straight down through the middle, and hopefully this color shows up well on both parts. All right, not too bad. And so what we get then is we have a semicircle here, we have two semicircles here and here. Now, I could go through using all of this information, and it kind of would be a little bit long, but we could do that. They want the area of the black region, so it's going to be this part, which would actually be half the area of the full circle minus this semicircle plus this semicircle minus this white circle, but adding in this other black circle. Well, the small white and black circles are congruent, and then this semicircle is the same as this semicircle. So if I take the semicircle out here, if I subtract it here, but I add it back in there, that gets me back to the same thing I was before. Same thing here. If I take that circle away and add this one in, it's the same thing. The shaded region, this black region, is half of the full circle. And so our area is 1/2 of pi r squared for the big circle. That's all you have to recognize, is that this big circle, half of it is black. And so we can just take half of that area. So we're going to use the radius of 24, and then do 24 squared times pi, and then just divide by 2, and then we'll find our final answer. Okay, so when we start to plug this in, if we want to do it one piece at a time, 24 squared is 576. So I'm going to do 576 times pi divided by 2, or if you want, you can do 576 divided by 2 and just get 288 pi exactly. So if I wanted an exact answer, the answer for the area of the shaded region or the black region is 288 pi. But we are going to go ahead and round that. Let's just pick to the nearest tenth. If we do 288 times pi, we get approximately 904.8 square units. And they don't, I think, ever tell us what the units are here. So we're just going to say square units. And we can abbreviate it like that. That's the area of the black part of the yin-yang symbol. Okay? All right, this next example, you'll get to see a little bit more how we do a composite figure. And it actually could be formed by adding areas together or subtracting. As we saw here, we subtracted parts there. But in example 2, we should just be able to add some areas together. So we have this plan for a miniature golf hole. The right angle is a central angle, so they're saying this is the center of the circle. All right, and we are going to find the area of that playing surface, rounding our answer to the nearest hundredth of a square meter. Now, I want to show you the best way to line this out. It's not the only way, but this is the best way to break this up into smaller parts. Okay, I can draw this line making a complete rectangle. Okay, so we have area of a rectangle. I'm going to use the uppercase A for area and then a subscript of RECT for rectangle. And then This is a triangle, so I'm going to add that area. And notice that I'm cutting into this circle. That's okay. I actually want to do that. This is the area of a triangle. And then this, everything else of the circle except what I've already taken out. Okay, I could highlight it for you if we need to, but we don't have to here. This part is actually 3/4 of a full circle. It kind of looks like a Pac-Man. Because if I take that right angle out, I'm taking out that whole sector. You'll remember we talked about sectors. I'm taking that sector away because I've already added that area in the rectangle and this triangle. So I only want 3/4 of the area of a circle. And so this area portion is actually 3/4 the area of our circle with a radius that is the same as that measurement. Okay. So our total area is going to be the sum of these three portions we found. And so I like to go ahead and make a plan here by writing out an equation with these things here. We have the area of our rectangle plus the area of our triangle plus 3/4 the area of our circle. Okay, and so those are the three things I'm going to find. If I break it up into three parts, that's easy enough to find. The area of the rectangle, super easy. We have a base of 3, a height of 1.7. So we have base times height for area of a rectangle, which is 3 times 1.7. And then the area of a triangle, we're going to do base times height divided by 2. Now that base and height is different than the base and height of your rectangle. And then area of our circle is, or at least 3/4 of that, is pi r squared, where the radius is actually the base and or height of your triangle. So we can do this part. 3 times 1.7 is 5.1. But then I have to find these other two values here. And in order to do that, we have to know this measurement. It's the base and height of our triangle. It's also the radius of our circle. Well, it's not given to us anywhere else, but notice that this segment is the hypotenuse, which is 1.7 meters. This triangle, if that's 90 degrees, has to be a 45-45 because these are congruent sides. That means that the radius of your circle, or the base and height of your triangle, remember base and height are perpendicular, so if I turn it this way, that's the base, that's the height, is going to be found using special right triangles. I'm going to come over here and show you how to figure that out. So if that's 1.7, remember that the leg of a 45-45-90 triangle times root 2 equals the hypotenuse. So we actually need to take 1.7 and divide by the square root of 2. And so that's what our radius and or base and height measurement ends up being. Okay? So if I call this x, that's 1.7 over the square root of 2. So x is approximately 1.20208. All right. So I'm actually going to multiply that by itself and divide by 2 to find the area of the triangle. Base and height of your triangle, again, are both this x measurement. And so if I take that, I could just square it, because multiplying it by itself is the same as squaring it. Then divide by 2. And that's about 0.7225. And then I'm going to take that same radius and square it again. Okay, so if I go back to that 1.20208 and square it, times pi, then multiply by 3/4, that's going to give me my area of the 3/4 of the circle. And this is what we get for that 3/4 of our area of our circle. about 3.4047. Now you may wonder why I'm putting so many decimals here. That's because I don't really want to round till the very end of my problem to the nearest hundredth, so I'm putting enough decimals shown to where it doesn't throw off my answer. Okay, this was exactly 5.1. This is actually exactly 0.7225 because we're squaring that part which is in terms of root 2, and so that's why that works out that way. And then we get this measurement is another little bit more rounded answer because we're multiplying by pi, but I'm going to add these together now. And get a total area that is approximately 9.23 square meters. All right, now we can move on to example 3. And in this example, another composite figure problem. The hardest part of this is figuring out what figures to put together. Fortunately, they've put our dotted lines in nice and neat for us so we can get started and it shouldn't take too long. All right, we have the dimensions of an irregular shaped pool given here. What is the area of the surface of the pool? Easy enough for us to figure out. Let's look at the pieces that we're putting together. In the middle, we have a rectangle. Okay, they've already kind of lined that out for us where we have a base of 32 and we have a height of 16. We have a triangle below that which has, again, we're going to assume that's a right angle. You can write it in if you want. Has one side that's 15 and another side that's 32. Again, treat that as base and height again. And then on either side we have two semicircles. Now, this semicircle has a diameter of 16 and so does this one. These semicircles would be congruent. In fact, these are both two halves of the same circle. So we really only have three things that we're adding together. First, we are adding the area of a rectangle again. Then we are adding the area of a triangle. And then these two half circles put together to form one full area of a circle. Okay, area of a rectangle is base times height. Area of a triangle is 1/2 base times height of the triangle. And area of a circle is pi r squared. And we have the full area of a circle this time. So I want you guys to find these three parts. Pause the video to give yourself enough time to do that, but find these three parts and then we'll add them together at the end. Alright, these are what we should get for the three areas that we're adding together. Alright, the area of the rectangle is 512 because we took 32 times 16. The area of this triangle is 240 because we did 32 times 15 divided by 2. And the area of your circle ends up being 201.06 about, which we got that from doing 64 pi. And if I add all those together, I should get this. That the area of the composite figure, the area of this surface of the pool, is about 953.06 square feet. Alright, that wraps up our notes on composite figure area, which completely concludes lesson 11.4. We'll start the assignment on this in class as well as finish up any parts of the 11.4 day 1 assignment that you received yesterday and move on from there.